Hello, everyone. Ah, brilliant. Okay, I've posted the information about the webinar like 5 minutes ago, and we have 38 people. That's very impressive. I'm really happy to see you guys. Yes, so you should have received an email about whether you're accepted or not. There has been a technical difficulty, but I think that all the emails saying that you are not accepted have gone out. So if you haven't received anything, that means you're in. So no news is good news, but I will make sure that everyone receives an email. So yes. Now, if you haven't been accepted, don't worry. You still have these webinars. You're still welcome to attend the webinars. And progress. Yes. What else? Okay, well, yes, without any further ado, let's go through some problems. And at the end, you will be able to ask me questions. You can ask me questions about particular problems. I will try my best to answer. Oh, we have Sean today visiting. Okay.
Hello. Yes. Hi. Yeah. Is it okay if I just introduce myself?
Yes.
Okay?
Yes. Please do. Please do.
Okay. Great. So I just wanted to say hello, really. So I am the designated safeguard lead for the department. So I am here to keep you safe. I'm your contact. If you have any worries or concerns, then you come to me. So it's just really to let you know that safeguarding and your welfare is our top priority. So yeah, if you've any concerns at all over this programme, then there's somebody that you can get in touch with. That's me. If you're feeling unhappy, unsafe, you have any concerns about other students or any of the adults helpers, any of those things, then please do come to me. I will put the email address that you can contact me into the chat. There is also a code of conduct for all of our events, and I just wanted to share that with you as well. I apologize if you can hear my daughter who's in the other room. I don't know if you got to hear that. So I can't share my screen at the moment. Would you mind could you give me permission to share my screen?
Yes, sure.
Thank you. That's great. I can see that now. So yeah, this is just our code of, oh, can you see that?
Yep.
The code of conduct, right, brilliant. Yeah, just to share the code of conduct that we've got for all of the events that we run in the department. And this is kind of the rules that we would like you to abide by, the rules that we abide by as well. And basically it's to be respectful, kind, nice at all times. So you're going to be working with your mentor for a long period of time. You're going to get to know your group. But yeah, these rules apply as you go along. Please do not share any inappropriate language or content within these forums. Do not share your personal details either. So it's just use the platforms that you've been given to communicate. Please don't try and contact our mentors outside of those. Do not contact each other. Do not share your personal details. That's something we've got to make sure that we keep you all safe outside of these events as well. And please don't record any of the meetings. We won't do the same. We don't have permission to take recordings of you, and we shouldn't. Please don't record any of the sort of tutor mentor sessions where you can be identified, and don't record any of your colleagues. We will record where we need to these webinars. So that's it really. As I said, I will put my email in the chat. I will probably pop in from time to time just to see you how all the sessions are running. So I will try and make it into all of the mentor sessions and into the webinars again. And you can contact me at any time. And we sort of wish you the best luck with the programme. Those of you who are going to continue with the webinars and those in the mentor sessions, that's excellent. And yeah, stay in touch. Thank you very much.
All right. Thank you very much, Sean.
Thank you.
All right. So back to me. Oh, where am I? Spotlight. Not in the spotlight. Now I am. Right. So yes. But by all means, if you feel something's not right with any one of our tutors, any one of your students miscommunicating, you can contact me or you can contact Sean directly. So please feel free. Now, also just one thing, if we will be moving away from Telegram. We are looking into options. So probably we are looking into using Slack instead of Telegram. But in Telegram, just be wary. Please make sure that your phone number is not visible. Yeah, so that there isn't. If you go to settings, make sure that it is not visible. By default, it's not visible. Okay, so it's only visible if you have actually made it visible. So if you haven't done that, you're probably your phone number is not visible. Okay. Right. So and let's move on. So the first problem is about some unsafe activities, as is motorcycling. Okay. Right. So a motorcyclist is attempting to make a jump over a pit, probably most likely with crocodiles. It's not specified. And they need to make it safely to the other end, which is h meters below the starting point. And it is the pit is s meters wide. And there's the angle, the ramp is at an angle alpha. And basically what they need to do is to complete the jump safely. So we model the motorcyclist as a single point, as we normally do. So we're assuming the motorcyclist is small compared to the size of the pit, which is not ideal. Of course, you understand. There's more things to be to consider when someone is making a jump like this. But we'll keep things simple. Right. So what do we have? We have a motorcyclist starting with speed u. Let's say no. Let's keep our notation that we used in the assignment, and I believe we used v0. So just maths, physics, 0. I shouldn't be showing you this. Physics 0 2. Yeah, we used v0. Okay. So this is v0. V0, which is the same as u, yeah, because if you know suvat, u is the initial velocity, so v0. And okay, so we need some coordinate axes, and we will put our coordinate axes at the starting point. The starting point. So this is the x-axis. This is the y-axis. This is the x-axis. And we can put this here. Just to make it slightly prettier. All right. So there are two motions here, the horizontal motion and the vertical motion. So we're going to write equations of the horizontal motion. Horizontal motion. And of course, it is x of t, x of time. So we start with initial velocity, initial position x0, plus, because it's uniform motion, the acceleration is 0. But we can write the whole thing out. x0 plus v0 x t. Yeah, that's the initial velocity in the x direction times time plus 1/2 a t squared. Acceleration is 0 in the horizontal motion, so that's x of t. And the initial position is also 0, so it's v0 cos alpha t minus 1/2 g t squared. That's, oh, sorry, what am I doing? This is 0, of course. Yes, so the horizontal position at any moment in time is given by this equation. Right. The vertical equation, the equation for the vertical, y of t is y0 plus v0y. So this is the initial velocity in the y direction times time plus 1/2 at squared. So y of t is, the initial position is 0, and then, well, let's not write this, it's 0. So it's v0y, so it's v0 sine alpha t minus 1/2 gt squared. Okay. Suppose that the motorcyclist lands, suppose the motorcycle lands at time t. So what happens at t? That means x at time, sorry, let's make it tau. Let's make it proper. Tau. A time tau. That means x of tau. So that's, the motorcyclist is here at this point. So yeah, the initial. So I'm just gonna draw it's more like this rather than the dashed line, more like this. X of tau is, well, it's s. And y of tau, can somebody help me? What is y of tau? Let's see how well you understand the notation. Where is the chat? That's not the chat. Minus h. Oh, yes, very good. Very good. Okay, minus h. Okay, Oscar, do you understand why minus h, not h? Yeah, okay, good. Because, all right, and then we just plug that in. So we have s is equal to v0 cos alpha time, and minus h is equal to v0 sine alpha t minus 1/2 gt squared. Right. And the thing is that this is where physics ends. So I'll just label, this is the end of physics. Not end of physics, but end of physics. This is physics ends and maths starts. Because there's nothing else to do. Your task is any question, ultimately, your ultimate goal in any problem is to get a set of simultaneous equations. Okay, So think of this as a physicist. What you need to do is to get simultaneous equations. And the number of simultaneous equations must match the number of unknowns. And in this one, how many unknown values do you have in these two equations? Don't tell me the number, just tell them what are they? What are the two unknown values in these two equations? Velocity and time, exactly. V0 and time. V0 and time are the unknowns. Everything else is given because you assume that you know them. H is given, S is given, alpha is given. So V0, V0 and time are unknown. And you have two equations. That means you can find a solution. You can find a single solution, right? If you've done simultaneous equations in further maths, you probably have met that. That if you have three equations and three unknowns, then you can find a single solution, probably. It doesn't always work, but in general, as a general rule, as a rule of thumb, it works. So two equations, two unknowns. Two equations, two unknowns. That means most likely a single solution. Okay. And no, sorry, not single. Most likely a solution. Most likely can find a solution. And I really encourage you to look for that. So if you have a problem, no matter how complicated, if it's impossible to break down into simultaneous equations, that means the problem is unsolvable. Okay. Like in general, any problem in the universe, any problem anyone has ever done, if it doesn't break down to simultaneous equations, it's unsolvable. Okay. Sometimes you need to do approximations to do that. Yeah. So one of them is ignoring air resistance. That reduces the number of unknowns. So you eliminate the unknowns until you get a solution, and then you try to generalize. Okay. It reminds me of a joke where a physicist designed a model that predicts the outcome of horse races. So you know when a horse is going to win, and the model is absolutely flawless. It predicts very well which horse is going to win, but the only problem is that it only works for a perfectly spherical horse in a vacuum. Okay. Right. So yeah, and I mean, solving simultaneous equations is obviously fun. I'll just outline how to do it, because so I think the way to go here is V0 cos alpha t. V0. Oh, interestingly, the method I thought, yes, obviously I didn't bother doing it beforehand. Yeah, you rearranged here. I was thinking going fancy with V0 squared cos squared and then adding the alphas, but that eliminates the alpha, and that's not what we need. Yeah, we just take t from the top is s divided by V0 cos alpha, and you substitute that into the second one. So minus h is equal to v0 sine alpha s over v0 cos alpha minus 1/2 g and then t s squared divided by v0 squared cos squared alpha. V0 cancels, and from here it's relatively easy to get V0 equals something. So you can work it out. Okay, I won't bore you with the details. After all, this is a physics problem, and doing maths, I'm sure you can rearrange equations. The point I was trying to make is this, and right. Good. Problem 2. This problem actually comes from thermodynamics. It's a problem about gases. A ball elastically strikes a plane moving at a speed u. At what speed does it rebound? Assume that the plate is very heavy. Now, it's an elastic collision. So in an elastic collision, kinetic energy is conserved. So if the plate is very heavy, that means the plate doesn't change velocity. And if the ball hits the plate elastically, that means that the kinetic energy is conserved. So the total kinetic energy should remain the same. Therefore, it should rebound with a velocity v0. That's what I thought when I saw this problem, probably like 25 years ago. And it does seem like it, but the thing is, there's a subtlety in this, and you will learn about this subtlety in assignment 07, I think, when we do kinetic energy. So if you think of energy, an elastic collision, if you don't know what an elastic collision, which is a collision which conserves kinetic energy. And it says the plate is very heavy, so it doesn't lose velocity. Well, that's impossible. You can't not lose velocity. You can't hit something and not lose velocity. If a tennis ball hits a truck, the truck changes velocity. Ever so slightly, but it does. There is a small change. It's just unrecognizable, unregisterable. But that means that if you throw a tennis ball at a truck, it will rebound at a faster speed, which is probably the case. So think of if you think about this problem, imagine a truck. Obviously, don't know how a truck looks like, but I know it has 2 sections. And imagine a tennis ball thrown at a truck at 10 meters per second. At 10 meters per second. Meters per second. What do you think? What do you think? So let's say the truck is moving at 10 meters per second. 10 meters per second. How fast do you think the ball will rebound? Would it rebound at 20? No, it wouldn't rebound at 20. Vin, how does it depend? Do you think if the truck was twice as heavy, there would be a difference? Doesn't seem like it. Doesn't seem like the weight of the truck makes any difference at all. Let's say elastic collision. Let's say elastic collision. Volodymyr, you think 20 meters, but due to the relative velocity. The relative velocity has a lot to do with it, but it's not 20 though. Zero. So you think so if you have a truck moving at you at 25 miles an hour, which is 10 meters per second, it's about 25 miles an hour, and you throw a tennis ball at 25 miles an hour, do you think the tennis ball will stop and just drop dead down? Seems. Well, you've never thrown a tennis ball at a truck, but have you ever thrown a tennis ball at a tennis racket, which is moving towards the ball? Replace the truck with a tennis racket, and you kind of see what happens. It bounces back, and it bounces back probably faster than. Well, a tennis racket. Look, guys, a tennis racket. I don't know how fast a person can swing a tennis racket, but I'm guessing the swing of a tennis racket is less than the speed of a ball, right? Look, if it's right, it looks like some people haven't received. Haven't received. I haven't received the emails. Anyways, the solution to this problem is quite elegant. You need to imagine that you are the driver of the truck. So if you're the driver of the truck, what do you see? What you look at the tennis ball. What do you see? You see the tennis ball flying towards you at 20 meters per second. Right, and then we remember. Then we remember the then you remember Galileo and well, a little bit of Einstein and a little bit of Newton, that motion is relative. So relative to you, the ball is traveling at, so you are stationary and this ball is traveling towards you at 20 meters a second. Ah, Jed, well done. You're the first correct answer, absolutely. The ball is traveling at you at 20 meters per second, so it will bounce away from you at 20 meters per second, okay? So you need to, the driver sees, the driver is stationary. From the driver's point of view. From the driver's point of view, the truck is stationary. The ball hits at 20 meters per second and rebounds bounce at 20 meters per second. To a stationary observer, the ball bounces back at 30 meters per second. So indeed, the ball will bounce back at 30 meters a second. And this is a very important result, 30 meters per second. Now, where does this come from? You would say, but conservation of kinetic energy. You would say conservation of kinetic energy. How is that possible? That kinetic energy is conserved, and yet the truck does not change speed, and the ball increases the. So where does the energy come from? Well, actually, the truck changes speed, but ever so slightly. It drops speed, but only by well, let's say the truck is traveling at v equals 10.0000 meters per second, and v0, and changes speed to 9.9990 meters per second. So changes ever so slightly. And if you actually do the calculation, that results, because the mass of the truck is quite large. The mass of a truck is typically what, 50,000 kilograms, let's give or take 50,000 kilograms. And if you calculate the kinetic energy, if you calculate the kinetic energy, so 0.5 times 50,000 times 10 squared, that's, so kinetic energy initial is 25,000,000 joules, and 0.5 times 50,000 times 9.999 squared, it's kinetic energy final is 249,9500. So that's a difference of about 500 joules. 500 joules difference down to kinetic energy. So if the truck loses 1 millimeter, 1/10 of a millimeter per second in speed, 1/10 of a millimeter per second, or is it? No, sorry, not one. Okay, 1 millimeter per second. So if the truck starts to move 1 millimeter per second slower, it loses 500 joules of energy. And 500 joules for a tennis ball, it's probably a tennis ball breaking the sound barrier. Okay. Is linked to conservation of momentum. Yeah, it is linked to conservation of momentum, of course. And so the kinetic energy of the truck changes ever so slightly, but the speed of the truck changes ever so slightly. But this change in kinetic energy results in a massive energy of the tennis ball. So that's why we have this. Okay. Relative kinetic energy exists as a valid measurement. Relative kinetic energy only exists if you are in an inertial frame of reference. So you can have relative kinetic energy as long as you are in an inertial frame of reference. An inertial frame of reference is a frame of reference that moves with constant velocity. So in a truck, that's not, because you are changing ever so slightly, but you're changing speed. Therefore, you can't use that. You can't use the relative kinetic energy in the case of a truck or the tennis ball, because it's changing velocity. And how does this answer the question? Well, let's generalize it for the truck and the ball first. So if let's say the truck. Oh no, that's not it. Let's say we have a racket. Just for simplicity, we have a racket, and the racket is moving with speed u, and the ball is traveling at speed v. They come together at speed v plus u, and they break apart at speed v plus u. Because the racket is traveling at speed u, the final velocity is going to be v plus 2u. And you can see it from this example. It's 10 plus 2 times 10. It's 30. That's the rule, and that's what happens to the horizontal velocity. So if you break down the velocity, so we have the horizontal velocities, which is v0 cos alpha, and the vertical velocity is v0 sine alpha. So vertical velocity does not change. Vertical velocity does not change. Horizontal velocity changes to v0. What am I doing? v0 cos alpha plus 2u. v0 sine alpha And so we have the ball, which rebounds. So let's draw the rebounding ball. And it has a vertical velocity, which is v0 sine alpha, and horizontal velocity, which has increased. Yes, so v0 sine alpha. And this is v0 cos alpha plus 2u. In collisions, we normally ignore gravity. Why 2u? That's a very good question. Okay. So in this question, you need to become the bat. Become the bat. You can think as you are a small bug sitting on the bat. The ball is approaching approaching at v plus u. Okay, the wall is approaching as v plus u. It will rebound at v plus u. From your point of view, from your point of view Okay, Andre, are you still with me on this? From your point of view. So from a point of view, but you are moving at with speed u. At speed u. So total speed of the ball is u plus v plus u. Sorry, v plus u plus u plus u, which is v plus 2u. Okay, yeah, thank you for this question. I'm sure you're not the only person that didn't get it the first time around, so don't worry about that. Yeah, horizontal velocity changes to v0 plus 2u, and yes, and then you can do some maths, because that's the end of physics. Physics has finished, and all we need is to find the, does it say speed? Yeah, it says speed, so they don't ask us for the angle, but might as well do the angle beta, and we can say, so v final is equal to square root, and then you just, okay, I'll put it here just to make sure we have the same. So this is the answer. V final is v0 sine alpha squared plus v0 cos alpha plus 2u squared. And there's really no point of simplifying that. It won't really make a difference. But it is a good practice if you want to practice trigonometry, because there won't be v0 squared plus v0 sine 2 alpha plus would it be wholly correct to take okay, Jed, think about if you were to hit something stationary, it would go faster than you hit with, especially you can easily demonstrate this by holding something still, then hitting it with your hand. Yeah, that makes sense. True. Isaac, I would be wholly correct to take it as the idea that we want our center point of operation, in this case, the racket or truck, to be stationary. We account for an observer after the fact, or would there be conjecture that aligns? I'm not sure what you mean. We account for an observer after the fact, or would that be conjecture that aligns? You just need to look at it from 2 points of view, from the point of view of the racket, or from the point of view of a stationary observer. Yeah, and then so you can simplify this, and that's an exercise in trigonometry, so please do that. But it's a nice thing to do. You should get something like v0 square root of v0 squared plus V0 sine 2 alpha plus 4u squared. I think so. Pretty sure that it is. Do get it by yourself. And the angle beta would be equal to arctan of V0 sine alpha divided by V0 cos alpha plus 2u. So here I'm just using trigonometry. I have this triangle. I have this triangle, and this is the vertical velocity. This is the horizontal velocity. The horizontal velocity is V0 cos alpha plus 2u. Yeah, the vertical velocity is V0 sine alpha. That should make sense. John, are we maybe which part? Which part? Yeah, I'm literally using Pythagoras here. So this is Pythagoras. So I'm looking at this triangle. So this is the final speed. This is the final velocity of the ball. And we know the horizontal velocity and we know the vertical velocity. Using Pythagoras, we find the resultant velocity, V final. We find it using Pythagoras. And the angle, we just use trig. So we use opposite divided by adjacent. Yeah, there's nothing new here. There's no new material. All the things you already know. The only new thing that I think I've taught you today is this. And this is an important thing. It happens, this explains why if you compress a gas, it heats up. Because a molecule flying towards a moving wall, so when you're compressing the gas and a molecule moving to a molecule hitting a moving wall will bounce back at a faster speed, therefore increasing the temperature of a gas. V0, yeah, it's going to be V0 squared plus sine squared alpha. Sine squared alpha, not sine alpha squared. Yeah. Well, this is also wrong because I think there's a 16th theorem of Landau who says that the number of brackets in a correct expression must be even. And you have 3 brackets. Okay. Oh gosh, we've only done 2 questions. It's been 15 minutes. V0 sine alpha squared. Yes, that is correct. And then you do V0 squared sine squared alpha. Problem 3, which is a more interesting one. Oh, this is a brilliant one. Okay. Oh, the trig questions that I've prepared for you today are quite easy, so hopefully we won't have time to get through all of them. A steel ball falls from 1.5 meters onto a steel plate and loses 25% of its speed. At T, it strikes the plate again, find T. Okay, so the ball falls from 1.5 meters, hits the ball, loses some speed, bounces back to a lower speed, and then hits the plate again. Now, this happens in a single vertical line. It's just drawing it from a single vertical line is a bit awkward, because then you go bounce, it bounces back, and then hits the plate again. Yeah, so this doesn't look good. This looks better. So this is tau, t equals tau. And the height is 1.5 meters, 0.5 meters. That's helpful. So finally, we get a problem with numbers. And well, we need to apply two equations. You can say two SUVATs here, as you would normally do in school maths, two SUVATs, but let's do it like this. So y of t is equal to y of t is y0, initial position, plus initial speed times time, plus 1/2 at squared. This is the general equation of accelerated motion, of uniformly accelerated motion. So we have y of t. So y is this, y, and this is 0. Y of t is y0, which is 1.5. Well, let's call it h for now. The initial velocity is 0. The acceleration is minus g, so minus 1/2 gt squared. So we need to find where it hits the ball first. Hits the plate. Hits the plate. The plate first at t equals t1. Okay, so y of t1 is 0, because when at the time, one thing I really want to emphasize here is that this equation is the equation of motion. It tells you where the ball is at any given moment in time. So at time t1, y is 0, and that makes sense. At t1, the y is 0. So when t is t1, yes, okay. So we get 0 equals h minus 1/2 g t1 squared. And we can work out that t1 is 2h divided by g square root. Okay. We also need the speed at which it travels. So we need v of t1. V of t1. And to find v of t1, we have the initial velocity plus acceleration times t1. So v of t1 is equal to initial velocity is 0 minus g times t1. T1, which is minus g multiplied by square root of 2h divided by g, which is minus square root of 2gh. Okay. So it hits the ground. It hits the ground with velocity equals minus 2gh square root. And it says it loses 25% of its speed. So it bounces back up with velocity, well, square root of 2gh divided by 4. Okay. No, sorry. That's very silly of me. No, it bounces back with 3/4, so it loses 25%. So it has 3/4 of its speed. Okay. So and now we have a different equation of motion. So we have y. So when t is greater than t1, y of t okay. So I really don't want to overcomplicate things here, but that technically would not be correct. So I would say, look, this is restart the timer. We restart the timer. Restart the timer at t1. So why do we do that? Because now we can write the equation, the simple equation. Y of t is equal to initial velocity, initial height, which is 0, plus initial t plus 1/2 at squared. So which will be y0, which is 0, plus v0, which is 3/4 square root of 2gh multiplied by t, and minus 1/2 gt squared. Now, if we didn't restart the timer, that would be a bit awkward. That would look like this: y of t would be equal to y0 plus v0y, t minus t1 plus 1/2 a t minus t1. And we really don't want to go there, like if we didn't restart the timer. If we didn't restart the timer. So what I'm trying to say is, sometimes you need to cut corners, because this just makes the problem unnecessarily complicated. Then this just simply means that the time here is not the same as the time here. But then you only need the time between the two bounces, so you're not interested in anything else. Okay, so and then we do that. We know that at the second bounce, the second bounce, we have 0. Y of t is 0. So we have 0 equals 3/4 square root of 2gh t minus 1/2 gt squared, and we get, well, one of the solutions is t equals 0. It's a quadratic equation. It's a quadratic equation in terms of t, and the other solutions we simplify and we get 2. So it's 3/2. T equals 3/2 square root of 2h on g. 2h on g. I think I've done it correctly. 3/2. Yeah, that makes perfect sense. And the total time answer. Total time is t1 plus 3/2 square root of 2h divided by g, which makes it square root of 2h divided by g plus 3/2 square root of 2h divided by g, which is 5/2, 5 on 2, square root of 2h divided by g. So that is 5/2 square root of 2 times h, which is 3, because h is 1.5 meters, divided by g, and g is 10, so square root of 0.3. Well, you get some sort of answer. 2.5 times square root of 0.3. 1.4 seconds. 1.40 seconds. 40 seconds. Okay, so I hope that makes sense. Not the most difficult question in the world. Just using equations and just using them carefully. Like in A-level terms, you would say just using 2 suvats for 2 stages of motion. This stage 1 is falling down, stage 2 is going back up. Right. Problem 4 is quite an interesting one. Two bodies move on a smooth inclined plane. One up the slope. Okay. Their initial separation is 2.5 meters. So we have two balls, two objects separated by 2.5 meters. meters. And one is released and one is moving up the slope. Which one is moving up the slope initially? It doesn't say in the problem, but can you work it out? Which one is moving up the slope and which one is released? The bottom one is what? The right one is moving up. Why do you think? The lower one is moving up. Yes, the lower one is moving up, of course, because otherwise they wouldn't meet, because the problem implies that they will meet. That means that the bottom one is shot up at 0.5 meters per second. 0.5 meters per second, and the bottom one is just released. Okay. Well, the thing is that you're not given any data. You're not given the angle, which is really annoying, because you're normally given the angle. So if you don't know the angle, you don't know the acceleration of the object, which makes it double annoying. But one thing that you must understand, that the acceleration of both the balls is going to be the same, because if you're on an inclined slope and there's no friction, you have the gravity pulling down mg, the normal reaction. So mg can be split into components, and this component is mg cos alpha, and this is mg sine alpha. And then if you go along the slope, so this is the x-axis. If you go along the slope along the x-axis, you have mass acceleration in the x direction is equal to the resultant force, and the only force is mg sine alpha. Mg sine alpha. So acceleration is g sine alpha. And here, the acceleration down the slope is going to be a, which is g sine alpha. We don't need to write g sine alpha because we don't know alpha. So what's the point of doing that? We'll just write a. Okay, so acceleration down the slope is a, and both balls experience the same acceleration. They both accelerate down the slope at a. Now we take the whole thing, and this is a copy. You can't do it on paper, but and ta-da! You just turn it. And then you point your x-axis. It doesn't matter which way. Let's point it. Well, I'm tempted to do it down the slope because it just makes more sense. So I'm pointing the x-axis down the slope. X-axis down the slope, and I'm going to make this 0. This is 0 on the x-axis. So we'll label them. This is ball 1, and this is ball 2. So x1 of t, let's write down the equation of the first ball, and it's the initial position, x0, which is 0, plus the initial velocity, which is 0, times time, plus the acceleration, plus 1/2 at squared. Okay, is everyone on board with this equation? Do you understand everything I did so far on a scale of 0 to 10, please? 10 being I understand perfectly. 12. Okay. Good. Right, perfect. So we have x1. This is the equation of x1. Now we need the equation of x2. Now it starts from 2.5. It is launched backwards, so minus 0.5 times t. And then it accelerates forwards because it's accelerating forwards. So it's accelerating forwards at 1/2 at squared. It accelerates forwards at a, of course, but the term is 1/2 at squared. Okay, and all we need is to find where they meet. So we have x1 t is equal to x2 t, and that is going to be 1/2 at squared equals 2.5 minus 0.5 t plus 1/2 at squared. Bam, bam. I bet you didn't expect that. So it doesn't matter. It doesn't matter how steep the incline is. They will meet after 2.5 divided by 0.5 equals 5 seconds. No matter how steep the angle is, and even if it was just a vertical fall, even if it's a vertical fall and one is released and one is moving up, they would still meet after 5 seconds. And another thing is that if you let's find the speed. So we write the equation for speed, v1 of t it starts with 0 initial velocity plus acceleration times time, and v2 of t starts at minus 0.5 plus AT. Now, when they meet, their relative velocity. So relative velocity is v1 minus v2. So which is AT minus 0.5 plus AT, which is 0.5 meters per second. Would you look at that? The relative velocity is 0.5 meters per second, independent of time and independent of the acceleration. Okay. Basically, what that says that if they are in free fall or they're on the same slope, the speed at which they move relative to one another is the same all throughout the journey. And yeah, basically you can apply if you go to the frame of reference, if you go into the frame of reference of ball 1, you are stationary. Yeah, if you become ball 1, you are stationary, and the ball 2 is moving towards you at 0.5 meters per second, and it keeps moving towards you at 0.5 meters per second, and you are blissfully unaware that you're rolling down the slope and you don't care. You just see the ball moving towards you. So imagine you were in free fall in deep space, and the second ball is just moving towards you, and you're both falling down. Okay. Right. So this is an. I really hope you can appreciate this result. It's I find it quite fascinating, honestly. Okay. Free fall be vibing. Not sure what that means, but probably is. Unless it's something rude, then it isn't. Okay, problem 5. Find tan 1 times tan 2 times tan 3, etc. times tan 89. Anyone? Can anyone give me an answer right away? It should be something really simple. Jed, yeah. But what is tan 45? Absolutely. Yes. So this is a very simple problem, and obviously, if you've done arithmetic sequences, you probably know that it's something to do with the first and last, and you understand that tan of 90 minus x is cotan x. Okay. And this can be proved in various ways. So for example, if this angle is x, this is A, B, and C. So tan x, no, sorry, cotan. Okay, cotan x. Cotan x is the adjacent over opposite. Is adjacent over opposite. And this angle would be 90 minus x. So tan 90 minus x is also b over a. So this is a simple proof. I'm struggling to call that proof, but well, yeah, it is proof. It is proof of that fact. Tan 90 minus x is cotan x. So therefore, tan 90, tan 1 is tan 90 minus 89, which is cotan 89. So tan 1 is cotan 89. So cotan 89, cotan 88, etc. And cotan, you know that tan theta multiplied by cotan theta, tan theta is 1, because tan is sine over cos, and cotan is cos over sine. So it's always for any alpha. Therefore, all of these are 1s. All of these are 1s, except the one in the middle, which is tan 45. But tan 45 is 1 as well. So the answer is 1. Okay. There is a somewhat similar task, which is well, it's more like a mathematical joke. It's not really a joke. It is a genuine problem. So you need to simplify x minus b multiplied x minus c multiplied, etc., until x minus z you need to simplify that. Does anyone know the answer? As I said, it's more like a joke. Andre, 0, why? Can you explain? Because yes, because there's one of the terms is x minus x, which makes it 0. So somewhere here, there is an x minus x, which makes the whole thing equal to 0. Okay, right. Find the domain of y equals 1 over sine x and sketch the graph. This function is also known as cosec x, and sketch the graph. So we know that sine x cannot be equal to 0. Sine x cannot be equal to 0. And we draw that on this, and we know that the sine is the y coordinate, of the on the circle. So it's not here and not here. So x is not equal to 0, and x is not equal to pi. What's wrong with this? What's wrong with this? Cosec, yeah, it's called cosec. What's wrong with me just writing this is not 0 and not pi? Yeah, well, I mean, k, 2k pi, you meant, risen. Yes, it has to be k pi, because it's not only 0, it's also 0 plus 2 pi k, and this is pi plus 2 pi k. But then it can be simplified, because you can combine these two and just say that x is not equal to pi k. If you want to sketch the graph, that means, so this is x and this is y. This is y. We know that this is 0. This is pi. This is 2 pi. And this is 3 pi. And it's division by 0 at these points. So these are vertical asymptotes. These are vertical asymptotes. Okay, just one more. These are vertical asymptotes. Now, also we know that, well, when x is pi over 2, sine is 1. So when x is pi over 2, sine is 1. So this is 1, and this is minus 1. So, and we know that when it's 3 pi over 2, it's minus 1. And then again, 1. Okay. And then we also know, so actually, you know what? We can sketch sine x. We can sketch sine x here, just to give us an idea of what it is. So this is sine x. Etc. Now we want to draw sec x. Cosec x, sorry. 1 over sine x. So 1 over sine x. So this is a reciprocal. So if sine x is increasing, like here, it's increasing, that means this one must be decreasing. So it's going from plus infinity to 0. And then if it's decrease, if sine x is decreasing, the reciprocal would be increasing. Yeah, because if the denominator is increasing, if the denominator is decreasing, it is increasing. It is, if the denominator is increasing, the function, the fraction is decreasing. And same here. And this rule can be generalized to any function. So basically what we did is we have found the reciprocal function. We found the reciprocal function. Whenever a function crosses 0, the reciprocal function would have an vertical asymptote at that point. So if you have a function like this, for example, y equals x squared minus 5x plus 6, and you have y equals 1 over x squared minus 5x plus 6. Okay, so you can sketch that. So the zeros are very important at this point. So if you have the original graph, which is 2 and 3, 2 and 3. So it's a graph that looks like this. And this is 6. And the reciprocal graph would look like this. So when it's 0, there's a vertical asymptote. Vertical asymptote. So it's going to go like this. And like this. So this would be 1/6. Okay. No, it's 2 and 3 because when x is 2, it's 0. 4 minus 10 plus 6 is 0. Okay, good. So we have a few more minutes. Yeah, that's usually what happens. You realize something while you're asking the question. Problem 7, Q&A. If you found a problem that you just don't know how to even just say maths questions that, or physics question that, and I'll open them. And I'll try to give you some hints. Tutors, you will be assigned tutors this week. Okay. Assigned. Alistair, can you give me a specific problem? Joseph, math problem 6E. Math problem 6E. Yes, I can give you a thing. Problem 6E. Oh, that's an easy one, actually. Not so. You need to write down what cosine is. So you start from the right. Cosine theta minus phi is cos theta cos phi minus sine theta sine phi. And then you write the same for the cos theta plus phi. A similar expression, and then you add them. That's it. That's two. That's quite straightforward. Alistair, problem, is that maths? Alistair, problem 7. Ah, okay. Try squaring it. Squaring both sides. Yeah, that's the extent of what I don't say about this. It pretty much solves the problem. Yeah. Joseph, you can, yeah, of course you're allowed to. You can modify the right-hand side, or you can modify the left-hand side. But that's not really what you're doing. You're just well, yeah, that's what you're doing. You're proving it from right to left. That is allowed. Physics. Yes, Alfie, you are allowed to use other identities to prove you are allowed to use other identities to prove the ones that you need to prove. Okay, so physics problem 2. Okay, physics problem 2. Physics problem 2 is quite, in a way, it's quite similar to the tennis ball and the truck. Not exactly though, but does have some resemblance. A plane whose cruising speed is v is flying from A to B and then returning to A. The speed of the wind is constant and equal to u. A to B. Well, let's say there's a headwind u. So the plane is, you're going there at a speed v minus u, and you're flying back at a speed v plus u. And then you use the average speed is total distance divided by total time. And that's it. That's, well, can't go any further. You just need to be very careful with this. Total distance divided by total time. And if it's flowing perpendicular to the line, so you're just flying, so if the wind is flying, let's say going like this, and you are, well, you have to steer the plane because if you're flying from A to B, if you steer the plane straight, you will end up not at B, but you will end up here because the wind will blow you sideways. Okay. I've actually flown a plane this morning, and this is what you experience, because when there's wind, you point your plane one way, but then you end up in a completely different spot, and yeah, it's quite annoying. So okay, then in this case, you steer the plane downwards, well, in a southerly direction with velocity v, and then u is u, and that's your total speed, which is square root of v squared minus u squared. And that's all I'll say here. That's your actual speed. That's okay, problem 16 maths. Okay. Find, by the way, if flying is something you're interested in, it's not as expensive as you think. So I rent a plane for £100 per hour. So, and that's only the engine runtime. So, I mean, it's not cheap, but it's not thousands and millions of pounds. And I do maybe 2-3 hours a month. So that's £200-300 a month. And that's the cost of flying. So that's not really, not extraordinarily expensive, but yeah. Okay, so and you can take it for a weekend, and you only pay for the flying time. So you take the plane for the whole weekend, and you only pay like £100 for And you can fly to Scotland in what, like, I don't know, 3 hours. So you just pay for the flying time. Anyways, what is the question? Problem 16. Find the values. Yes, that's a brilliant question. That is a brilliant question. Find the values of A for which the equation has 3 distinct roots on the interval. Okay, find the values of A for which the equation has 3 distinct roots on the interval. Well, first of all, you start thinking, okay, this looks like a quadratic equation, right? Is it always a quadratic equation? Well, it's not a quadratic equation if A is 0. So let's investigate. So you investigate. So what if A equals 0? Then it's not a quadratic. It becomes minus A minus 1 sine x minus 1 equals 0. So sine x equals 1 divided by 1 minus A. And on the interval from 0 to x to 2 pi, can this have 3 roots? 3 distinct roots. It only has 3 because on this interval it's either 1, 2, or 3 roots. Well, obviously 0 roots. So if this is 0, because sine x equals 0 has 3 roots. 3 roots on this interval. So it's not. So A equals 0, we have 2 roots. Yeah, we can't have 3 roots when A equals 0. Cannot have 3 roots when A equals 0. Okay. And then, so let's suppose A is not 0. So then you solve a quadratic. You solve a quadratic. It has a solution. So you have sine x is equal to, use the quadratic formula. It's A minus 1 plus or minus square root of A minus 1 squared minus 4A times minus 1, so plus 4A. So this is divided by 2A. So that makes it A minus 1 plus minus A plus 1. A minus 1 plus minus A plus 1. So 2A. So it's either 2A over A. So it's either 1 or 1 over A. Okay. And then you work from there. So basically what you see is how many solutions does, so basically you have 2 equations. Sine x equals 1, sine x equals 1 over A. This has some solutions, this has some solutions. You need to work out for which values of A does it have 3 in total. 2 there and 2 there. So I hope that makes sense. So basically what you're trying to achieve is how many solutions in total for every single value of A. So let's say you change the value of A and yeah, basically you need to say You can check different A's, for example, and see if it has solutions. Hope that's making sense. So sorry, I lost the chat somewhere. Okay. Right, 16A then. Got the email, yes, whether or not Amanda Dawn. I'm very sorry for the email. So basically, my email server said that you're sending out too many emails. You're probably a spammer, and probably a spammer, and that's what happened. So basically, they blocked. Yeah, so I can't find an. Oh. Right, Amanda, you'll need to text me your name because I can't find you. Sorry about that, but I'll have a look. Living the life. Yes, type of plane. It's an Icarus C-42. Top speed 90 miles per hour. Still gets you places. Diagrams helped. Can I have a hint of maths? Okay. So I won't have time. Sorry about this. I won't have time to do any more questions. How much is to learn? However, so a minimum of there's no minimum. So a pilot at 16 years, a 16-year-old pilot can finish training in under 20 hours. Okay, so less than 20 hours and you are a licensed pilot. So do you do the maths? But you do need to pay for an instructor as well, so which is about £50, so £150 per hour times 20 hours, which is roughly the minimum. And yeah, so that's your total price. Plus you'll need yeah, some equipment, but nothing extraordinarily. Sin x equals 3. Have 3 roots because it's 0, pi, and 2 pi. Okay, Samuel, it's sin x equals 0 has 3 roots. Yeah, but you can't have sin x equals 0 here because a is there's no value of a you can substitute to make it 0. So this was just I was just giving you an example that sin x equals 0 has 3 roots, but there's no way you can make it 3 roots. Sorry. Yeah, so all other values will not give you 3 roots. Sine pi is 0. Sin x equals 1. I only have one solution. Yes. Okay. Amanda, is that your Google? Is that your name in Google? And maybe text me which group you're in. This might help. Yeah. Okay. Yeah. So you just just text me on. I'll have a look. I'll have a look. Yeah. So yes, please text me which group you're in, Amanda, so I can look you up. Otherwise, right. So I hope this was informative to you, and you will be assigned tutors this week. Oh, and good news, everybody. Drum roll. The deadline for the assignments have been extended by 1 week. Okay, so the deadline is now the 13th of November. Yes, so this is in order for you to get to know your tutors, get to know get to know your tutors, get some help with them. However, I do not think we have the capacity to move the next deadline. So we will publish the next assignment this Sunday, so you can start doing it. But I can't promise you that we will move the next assignment. So the next assignment will be coming quite soon as well. So we will have only 3 weeks. The deadline is supposed to be the 27th of November. Okay, so just keep that in mind. Yes. Need to do all the questions this time. Brilliant. Okay. All right. See you, everyone. Void classification. So with tutors, so how it works, you will be assigned a tutor, and the tutor will offer you maybe 2 or 3 different times they are available. And if you're not available at these times, we'll need to switch you to a different group. Okay. It will take some time to jiggle people around. Yes. Now, the invitation emails are, you mean the invitations to groups? No, the groups are forming. We have completed about 15 groups. It takes time. It will take some time. Some of you will receive information about their tutor today. Some will tomorrow, etc. Okay, so by the end of the week, all the groups would be formed. They're not random. We put people that had similar scores in tests. So if you scored 80-80, you're more likely, you'll probably be in a group with people who scored 80-80. Okay. All right. Okay, see you everyone. Hope you enjoyed that. See you. Oh, the chat. Amanda. Did you text me the group? Sorry, Amanda. Are you still here? No. Okay, that's fine. All right, see you everyone.